Hi, everybody, and welcome to Ship It Safely with GitHub Advanced Security. I'm Brian, and with me today is Joseph. So we're going to share a lot of great information with you. I don't know, apologies if we're going to have time for like an in-person Q&A. Maybe it's going to depend on how fast we get through the material. But please ask questions. I know there's a QR code to ask them online. We've got a bunch of great subject matter experts who are going to answer as best they can online, and then if we have time, we'll try to save some time, but I wish I could make promises. So what do we have in store today? Well, first, again, I'm Brian. I'm the product lead for GitHub Advanced Security for Azure DevOps, or we sometimes like to call this one GASDO for short, because it's kind of a mouthful if you say the whole thing. So I'm the product lead for GASDO. The big news, as you can see here, is that we are available in public preview right now. If you went to Amanda's keynote this morning, she did the big announcement. Like, I always wanted to do like the get on stage and drop the mic and walk off, but like Amanda beat me to it. But we got too much good stuff to share anyway for me to walk off stage at this point. I promise I'm going to share the sign up URL with you in just a few minutes if you are very, very eager to get started. Love it. So today we're going to talk about first, like why GASDO? Not just the name, but like why is it an important product? What pain points is it going to solve? Why would I be interested in this? After that, we've got about 20 minutes of live demo of it. Really, that's the heart of it. We're going to walk through using it and see all its features and benefits. One more quick slide to talk about availability and billing. It will be a paid product starting June 1st. And then another really, really great demo of our sister product, Microsoft Defender for Cloud, and how GASDO and Defender for Cloud really collaborate better to bring you like a much better together story. And at that point, I'm going to pass things off to Joseph, and Joseph is going to show amazing demos. You're going to love it, of GitHub Copilot and how you can use Copilot to address the security issues that we find with GASDO. So it's going to be spectacular. So why GASDO? Well, the big reason is that application security vulnerabilities are still the main way that people get hacked. Think of your kind of OWASP top 10s, your CWE SANS top 25s, your 24 deadly sins, these kind of things, SQL injections, cross-site scriptings, overflows, bad crypto. These are still the #1 way that attackers exploit organizations like yours. And it's not just about the code that you yourself are writing. Like we're all in this room. I know at Microsoft, we're huge users of open source. So you've got to not only make sure your own code that you're writing is secure, but you have to make sure that the open source that you're using is as secure as it can be. And there's one of these vulns, one specific vuln, that stands out way above the others, both in terms of prevalence and impact. And that's exposed secrets. So we do a lot in GASDO around both detecting exposed secrets and, even more importantly, preventing them in the first place. So this is where GASDO comes in. So there are 3 main pillars to GASDO's developer security defense. The first, we have code scanning with a very powerful static analysis SAST tool called CodeQL. And this is going to be the tool that helps ensure that the code you yourself are writing is secure. The second is dependency scanning. And this is going to help ensure that the code that you're consuming from others, your open source, is as secure as it can be. Think of your log4shells, if that's not too painful of a memory. And again, secret scanning, it's a very special case that has to be handled specially and remediated specially. And we're going to spend a ton of time in the demo on secret scanning. Now, those of you who are GitHub users also have had access to GitHub Advanced Security for GitHub for a number of years now. And again, we're really delighted to announce that it's also available for Azure DevOps now as well. And they're native features built into Azure DevOps. So it's not like calling out to anything. We have built these protections directly in. It is literally as much a part of Azure DevOps as Azure repos and Azure pipelines. Completely native features. And I also want to highlight that these are features to protect Azure repos and pipelines. So if you're someone who is using, say, Azure pipelines to build GitHub repos, then the product you want is GitHub Advanced Security for GitHub. Let your GitHub Advanced Security follow whatever repo system you're using. But if you're using Azure Pipelines to build Azure repos, then here's a demo. All right, so the first thing I'm going to show is just how incredibly easy it is to get started. So I'm here in my repository settings, and I'm going to work out of eShop on Web today. I'm going to put my hat on as a developer working in eShop on Web. And this is it. Like this configuration toggle at the top, when I click this button on to say turn on advanced security for this repo, that's literally all it takes to get started with secret scanning. Like what this is going to do, so wait, before I get there, you see there was like nothing for me to install, like nothing for me to maintain. Like, there's nothing even I have to configure. It's just click, and I'm done, and I'm ready to go with secret scanning. And what this does when I click this button is it starts off a background scan, a background service that's going to look through this repo and look for exposed credentials. Not just tip of main, because an attacker wouldn't just look in tip of main. If some attacker got illicit access to your repo, like they would look through all the branches. They would look through your entire commit history for creds. So that's exactly what we do too. We look through your entire repo, all commits, all branches, and if we find anything, we're going to raise that as an alert here in our new alert hub UX in a repo view. Again, we're a very repo-centric view. So this is the dependency tab. Let me skip over to secrets. So in this repo, again, completely historically, we have found 4 secrets. Some Azure stuff. You see even an AWS cred here. Like we are of course looking for all the Microsoft and Azure stuff, but we have a big partner program too. So it's not only going to catch those. We'll catch Amazon and Google and all the ones you can imagine. And let's say I want to dig into this. I want to find out more. Again, I'm a developer. I'm responsible for fixing these. How do I do that? And I'll go check out this pat. And you can see here's all the places that it's detected, even in the various commits. I can navigate to that, and it's going to highlight exactly where it is. And if you saw the last session, this is the same one we exposed. I already revoked it. You don't need to try. And really good recommendation of what to do to move forward. Now again, as I keeping my hat on here, as the developer responsible for this repo, I've got to go fix this. I can't just ignore it. This is a huge security hole. Like, this is how, what is the stat that I saw? 80% of web application breaches are because of exposed creds. Like, that's a huge number. And consider the impact of what would happen if some attacker got access to this. Like, just if an attacker gets access to, say, a dev machine, maybe they get it through phishing or some other ODay or whatever, that's bad enough. But if they can then look through your source control and find all your production creds and escalate themselves up to your production systems, that is a way worse problem. So okay, this is like the problem of exposed credentials is terrible both in prevalence and impact. So I can't just ignore it. I've got to do something about it. But what is it that I have to do? Well, it's not just push a new commit over top, right? Creds are really unique this way. Again, think of all your other AppSec vulns. Like, how would I fix a SQL injection? Well, I'd find the vulnerable line of code. I would fix the code snippet. Actually, Joseph is going to show some amazing ways to do this a little bit later on. I'd build that code that fixes the SQL injection, and I'd deploy it to my customers, and now the problem is solved. But creds don't work that way. You can't fix a cred just by building new code or deploying new code. As soon as it touches the repo, I'm done. I don't know what attacker has seen it at that point. It could be there's people watching my network right now, and as soon as it touches any repo, they're going to go exploit it. So the only way forward for me, once the cred actually makes it all the way here, all 4 of these, the only way forward for me is to kill these things permanently. That's it. And before I do that, I've got to go figure out all the places that it's actually being used in production. Because if I go kill it right now, I'm probably going to take down a bunch of systems. So here's what the rest of probably a few weeks for me at this point is going to look like. I have to run down every place these are being used in production. I've got to get those rotated to a new one. Then I've got to permanently kill this thing, and I've got to cross my fingers that I didn't miss even one place that it's actually being used in prod, because if I did, I'm about to cause a live site outage. So it's toil and it's stress because of these. Now I know you're waiting for and the good news is, in Gazdo, we are focused on helping you never get to this point in the first place. Yes, once you get to this point, you've got some cleanup work to do. I'm not going to sugarcoat that. But what we can do is make it so you don't get to this point in the first place. So now let me switch out to Visual Studio. I'm keeping my developer hat on. And I'm going to write some new code. You see I'm a super, super fast typist, by the way. And I'll scroll over and, oops. Looks like I've accidentally put a cred in this bit of code. It's super easy to do. Like, who here hasn't accidentally done this? Like, hey, I'm just prototyping something. I know this has to go into Key Vault. I promise I will fix it before I push it up. Just let me go test it. And of course, your test doesn't go as expected, and you iterate a few times. And you're like, oh, I finally got it working great. Push. Happens all the time. So that's what I'm going to do here. I'm going to say new feature, and I'm going to commit and push that. And now what's happening is, as this goes up to Azure DevOps, it's going to scan that, and it'll have detected that the push contained that secret. And it's going to reject the push. And this is really, really nice. This is a much better way of dealing with the secret. So now what do I have to do? Do I have to permanently revoke this cred? No. Do I have to hunt down every place it's used? No. I just have to clean up my commit because I haven't actually exposed anything yet. Yes, it went up to the server ephemerally, but it did not get stored anywhere. It went up, it was analyzed, and it was rejected. So again, now I've got a very easy way forward, like 5, 10 minutes worth of work to move this cred out to Key Vault. Squash merge, I will highlight that squash merge is important here, because if I just push a new commit, then this will still be in the commit history you're pushing up. So fix it, squash merge it, push it back in, and you're done. Again, 5 minutes worth of work versus weeks of stressful toil. So we really, really love this solution as a shift left. Sorry, the question was what? How do you do it for GitHub? So how would you do the exact same thing for GitHub? Well, you would get GitHub Advanced Security for GitHub that has the same push protection built into GitHub repos. So that's been there, and it's been great. And now we're bringing that to Azure DevOps repos as well. So sometimes I hear questions like, hey, can't you just do this at PR time? Nope, it's too late. Because at that point, you've already pushed your cred into whatever your topic branch is. So it's exposed at that point. Like PR analysis is not the same thing as push time analysis. Another thing I hear sometimes is, oh, let's shift it even further left to the client. And yeah, that can work. That's good. But now you've got to maintain all these clients. You've got to ensure that every single one of your developers, every single one of their IDEs has the protections installed, which is incredibly infeasible for most organizations. And you'd have to make sure that they got kept up to date continuously. And that's also infeasible for most organizations. So we think this is the absolute best way. It's a single place. I'll get to you in just one second. It's a single place that you can turn it on and catch it right at the last moment before it becomes a much bigger problem. And look, it was so fast. Like if you don't have a secret that you're committing, you're never even going to know it there. Look, it took 7 milliseconds to run. It is super blinding fast. You'll never even know this is there unless something goes wrong and then it steps in to catch you at the last minute and help you fix it before it becomes a bigger problem. I'm going to take a couple quick questions and then I'm going to move on. Go ahead. Yep. So the question is, hey, we've been using Azure DevOps for years. Like, how am I going to fix the backlog? Well, they're going to show up here. Like, if you are looking for a magic button to press that's going to make these go away, we unfortunately don't have that. you may see things come in the future that help you on this journey, but there's no getting around the fact that it's going to be some manual effort. Like we can even tell you all the places the secret is exposed in source control, but we have no visibility into like where it's stored securely. Like we can't go through your key vaults. We don't know if you've passed it on to customers of your own. So like it's on you. Again, and that's why it's so important to keep it from getting to that point. There was one more question that I'm going to keep going. Variables will still get caught. That's fine. Variables will still get caught. That's the question is, what if I store it as a variable? If you've got it, like if it sees that secret anywhere, even like defined in a different part, it's still going to get caught. Okay. All right. So, go ahead. So the question is, are you stuck until you fix the problem from the push protection? Well, so you can always hard reset back to a point before you put the cred in. Like, it is not scanning the complete history of the file. It is just looking at the changes that you are committing up. So if you back it out to a point before you did the bad thing, you're okay. All right, so I'm going to move on to dependency scanning. Again, the supply chain security, log4shell, like yeah, I know it was painful for me. Like at the time, I was responsible for a lot of the log4shell response, and I don't want to say it was easy for me, far from it, but I think I had an easier time maybe than a lot of other people did, because even back then, internally in Microsoft, we were using the advanced security dependency scanning. So when I needed to know where all my vulnerable log4j was, I could just come to this view and see, like, here's all my log4shell vulnerabilities, and I knew exactly what I had to do to go patch that. So here I can dig in and get some really succinct fix guidance. So in this case, I've got a vulnerable system drawing common, and I'm using 500, and that's got a critical severity vulnerability in RCE. So if I get that to 503, I'm going to be fine. And I don't have enough time to actually do it, given the length of the build, but if I made the change and queued up a new build, the analysis would run, and then like this vuln would completely disappear from the list. So let me go back and show you. So actually, instead of disappear, it would move to state closed. So here's one that I fixed a couple weeks ago. So a DNS CVE that I patched, and now it's in state closed. Now one thing here, unlike the awesome secret scanning that we can just do it with a single click, both for the get clean and stay clean, dependency scanning happens in the context of a build. And the reason that we do it in the context, and I'll show you. The reason we do it in a context of a build is so we get a really, really thorough and accurate analysis. That's really important to us. See, and it's not super heavy lift. So it's really just that one task that I put after my build. And the reason I put it after the build is so that I can see exactly, what that's doing is checking exactly what components got resolved during the builds, like all the NPMs, all the NuGets. Let me pop out to a run of this. And you can see all the things so here's all the things it's looking for. So NPM, NuGet, pip, Ruby, CocoaPods, Go, Gradle. So it's looking for a lot of stuff. It found 276 NuGets, and it knows the exact versions of it. So it's not trying to interpret what version it got from like parsing a lock file. By virtue of having it in the context of a build, we just see, oh, it was exactly version blah, and then we take that inventory, and then we check that against the GitHub advisories database, which is like huge. Actually, I brought it up here so you can see it. Like the second biggest CVE issuer in the world now, like these are only an hour old at this point, checks for anything there that is known to be vulnerable, and then those, again, get raised back here as alerts in the Advanced Security Alert UX. Oh, one thing a lot of folks ask is, Hey, I use GitHub, and GitHub has this awesome thing called Dependabot. Does Gasto have Dependabot? So for those who may not be familiar with it, Dependabot is going to take this information where it says upgrade from 500 to 503 to fix the vulnerability, and Dependabot just generates the PR for you. So you don't even have to go do the work. You just say, yep, looks good, and merge the PR. It's not in Gasto today, but we have it under active development right now. We're really excited about building it. I don't know when it's going to make it into the product, but hopefully really soon. I'm very hopeful that at the next big show I can come on stage and show that to you. So it's not there, but we are certainly working on it, coming soon. All right, last one I want to show is code scanning. So this is the deep SAST analysis, OAuth top 10s and more. Actually, I can go out here to CodeQL query help. And this is the GitHub website. And you can see all the languages that it's got, C#, of course, C and C++, Java, JavaScript, Go, like tons of stuff. What kinds of things is it looking for? Here's just a few. Deserialization problems, bad crypto, bad randomness, LDAP injections, SQL injection, XPath injections. Like you get the idea. And it also runs in the context of a build. You might have seen the CodeQL task alongside the dependency one when I had it there. So what the task is going to do is really two things. The first is, again, this is just the way that CodeQL works. It builds effectively a searchable database of your code and the data flows. And the second piece to that is once it's got that database of data flows, it executes queries, so code query language. It executes those queries against that to see if any of those data flows are vulnerable. So let's keep going on the SQL injection example. So SQL injection is going to look for, do we have any data flow where the data starts from an untrusted user input and it flows all the way to a database call without going through some sanitizer in the middle? And if that data flow exists anywhere intraprocedurally in your entire code base, then it's going to raise this as a vulnerability. And that is exactly what happened here. And again, it's going to show you exactly where it is, what line of code, what commit, a really, really good recommendation, even a code snippet. Although, again, Joseph is going to show you a really, really awesome way to apply Copilot to this problem in just a few minutes. One more quick thing before I move on. Oops, I shouldn't have gone off that. We try really hard to not raise false positives. Like the theory, the principle of GitHub Advanced Security, both for Azure DevOps and for GitHub, is to be developer-focused tooling. And we can't be developer-focused if we are raising hundreds or thousands of false positives for you. That's just not our approach. We're not trying to win on volume. We're trying to win on accuracy and importance and confidence. So that if we're raising something to you, you know that this is something real that you should act on and not a like, oh, this is going to be another one of 1,000 false positives. Like we have very high confidence in what we're showing. But that being said, we're not perfect. So we do have a gesture here to just say, I accept this risk, or I triaged it, it is in fact a false positive, and close it out. Now this also kind of, there will be, I'm sure there are people here who are a little nervous about this and say, okay, like I get that you can close out a false positive, but you can't have it so that a developer can close out their own issue because that's a separation of duties problem. Like that would cause me compliance. Or even like, I just don't want that in my org, I'm scared about that. So if that is the scenario you are in, you can adjust the permissions that we baked into Gasto to say that contributors and people who are allowed to close alerts are in different sets. So like normally, a contributor would be able to close an alert, but I need that higher degree of confidence, so make it that only security reviewers can dismiss alerts, or only project admins, or whatever you choose, to get that separation of duties. All right, now, with that, I'm going to pop back to my slides. I'm going to briefly talk about availability and pricing, and I'm going to do one more demo. So it is available now that we teased out already. And here's the way that it's billed. It's billed at the same price as GitHub Advanced Security for GitHub, which is $49 per active committer per month. So the price is the same, but the model differs a little bit. In Gazdo, we are straight metered usage. So what happens here, like you saw when I started up, I said I'm going to turn on Gazdo on this one repo. So you can enable it on a repo by repo basis. Like I hope it's a lot of repos, but it's a repo by repo basis. And then every repo where you've enabled it, we're going to count the active committers every night at 12:01 or something, and then emit a partial bill to your meter. So there's no commitment. You can literally scale up at any time without talking to us. You can turn a repo off and pay less at any time. If you're like, this isn't for me anymore, you can just turn it all off today, and you won't be charged tomorrow. So very, very fluid, zero commitment. And we also dedupe at the subscription level. So you'd be like, okay, what if I contribute to multiple repos? You won't be counted twice unless that's to, like, you have different ADO orgs on different subs. Now the last thing is, just because we're in public preview, it doesn't mean like it's already lit up for all of you in your ADO orgs. Like, please sign up through this link if you're interested at aka.ms Advanced Security sign up. We are reaching out to everybody who is signing up to book like an onboarding session to give a little bit more white glove hand-holding. But we'll get you in the list if you want to sign up, and then you're good to go from there. All right. Beyond just the cool stuff in Gazdo, we have some great integrations. And the first one of these is Defender for Cloud, which is a really great better together story. Again, you saw that Gazdo is very developer-centric. One of the great things that Defender for Cloud brings is a broader overview, not just a view into a single repo, like a deep view into a single repo, but a broad view across all your repos, all your Azure DevOps repos, and all your GitHub repos together in a single place. And even more importantly, it brings like a really powerful code to cloud contextualization to see like what these things look like actually in production. So I'm going to switch over to that. So back to, thank you. So here I am in Defender for Cloud overview, and I'm going to go into the DevOps security preview. And I can see here I've got a bunch of GitHub repos, a bunch of Azure DevOps repos, and I can see their security status. Like here I've got some with OSS vulns. I've got a bunch with IAC vulns. Here are the CodeQL, code scanning vulns that it's found. Let's say, again, I want to search broadly across my organization, or across my enterprise. Yes, that's a good recommendation. Yes, it's a good recommendation. Oh, I can't, oh, geez. Let me try to get it to a point where I can. Yes, it will help me secure my resources. There we go. Okay, so now I want to see, I'll see if I have any log4j. I honestly don't know if I do. Like, do I have any log4j here? Nope. Okay, that's probably a good thing. Let me look for. Oh, I see some Express. So, how about some Express? Okay, I've just got the one. But you see, like, if theoretically, if there were some huge supply chain problem that came up overnight, and you want to know where all your vulnerable blah is, you're going to have a single place to go see it. Or even you can go search by an individual CVE. Show me all the CVE 2023-999 in my organization. Boom, in a single place. Yes, that's OK. I can also do cool things like search into production. So here I am in Cloud Security Explorer. I've got this cool one where like show me all the log4shell. Like that's a nice one. I'm going to try to build my own here. So I'm going to do all of my repos that are public, because it's bad enough when you find, let's say, exposed creds in a private repo, but in public, that's a whole different problem, that have vulnerabilities. All right, search for that. And now that's going to show me when that finishes. There we go. I've got a few of those too, and now I've really got to prioritize that. Think of this as a way to help prioritize my work. It makes a big difference whether something is just in developer in the dev part of the workflow versus maybe deployed to 1 million folks. So again, we love MDC as a partner product. All right, now with that, I'm going to welcome Joseph on stage to show another great way that we have a collaborative, awesome sister experience to Gasto. And that is going to be, while he starts up, GitHub Copilot. So take it away, Joseph.
Thanks, Brian. Hi, my name is Joseph, and I'm a developer advocate at the GitHub Security Lab. Together, let's explore 3 ways that GitHub Copilot can help with software security through 7 demos. Let's get started. I'm taking over from Brian through this dashboard I have on my screen. And I'm going to base all 7 demos in the SQL injection that is the second alert here. I'm choosing this vulnerability because it's very critical. Attackers can extract sensitive data from our database with that. So I'm switching to VS Code right now. We have this file order controller, and I'm going to the reported line that the vulnerability was given to us. If I zoom in, we see a vulnerable pattern in line 59. I put a breakpoint to highlight that. In that plus order GUID plus. It's a variation of a SQL injection. There are dozens of variations that SQL injection can happen. And let's get started with the GitHub Copilot chat functionality to see how we can first remediate that. A reminder that I'm going to execute everything live today, which makes it a lot of fun when it comes to AI-generated responses. It's not deterministic. I'm not sure what's going to be given back to me, but it's going to be very insightful for everybody here to see how I will try to recover with them with prompts. So let's get started. I will just slide a bit more here so that you can see the pattern. And let's get going. Can you please propose a fix for the SQL injection issue in line 59? OK. Off to a good start. What we have on screen is code that is secure because it's using parameterized statements that dissect the user input. And when it is malicious, it can really be harmful for us. I think this is big. And it's big because our research shows that there is 1 application security professional for every 100 software developers. Let's visualize this. That's a room of 300 seats. Just imagine that these 3 seats are the application security professionals, and everybody else in the room is a software developer. We try to minimize this gap by using the power of AI. Another step we took towards this direction was a few months ago when we released the vulnerability filter for GitHub Copilot, so that when code is suggested to you, we try to block vulnerable suggestions from being presented to the developer. So we could name this first demo, Write Safer Code with GitHub Copilot, not just fixing a vulnerability. However, here comes a big disclaimer. The best practice is to test all your code, not just the code that has been suggested to you, but all your code. And this is because GitHub Copilot has been built to be your AI pair programmer, not your secure coding expert. You are the pilot, and GitHub Copilot is a co-pilot. I would like to use an example for you to visualize this even better. I scroll up to the welcome screen, and we see here this predefined prompt, propose a fix for the bugs in my code. I will go ahead and click it. OK. And that's a prompt that I was not expecting to be like that. So let me prompt in a different way. Can you please always practice kindness? Can you please list the security issues in my code? OK, here we go. It matches what the CodeQL dashboard gives us, but just in the SQL injection. This is because GitHub Copilot chat, when it comes to security, our research shows that it focuses on the file that you have open right there next to you when it comes to security. It's a design choice just to help you as your pair programmer to focus on what's wrong in that file. CodeQL, however, it's an advanced tool with taint tracking and data flow capabilities. It's a proven and reliable way to pick up security bugs in your whole code base. The way it's built, it's following data around, and it knows when something is a true positive. So just to summarize the disclaimer again, the best practice is to use the tools together for what each of them excels at. Having said that, I would like to continue with a few ways that you can use GitHub Copilot with CodeQL. Let me first prompt, and I will explain the reasoning behind. Can you list, or can you provide, OK, can you please, I'm going to follow the suggestion in the first row here. Can you please provide a few CodeQL queries from the CodeQL query set that are suitable for the specific issue in our code? Let me explain why I do that. Bryan mentioned the Log4Shell vulnerability, 9 of December 2021. We were pretty fast on that because almost nobody writes CodeQL queries from scratch nowadays. We base our queries based on existing queries in the standard query set, that it's a community-powered query set from GitHub, from the community, from bug hunters, and from enterprises around the world. So someone will have to read CodeQL code and understand, find a generic suitable query, and then tailor it accordingly to match the Log4Shell. With that, I am more productive. What I have on screen is 3 suggested queries that are suitable for a SQL injection in a generic way, and I can then prompt towards tailoring one of those to make it more specific on the variant of the SQL injection I have in my code. Let's continue. Can you please customize then one of the above CodeQL queries so that it's better suited to our code? Let's check. OK, nice. We have CodeQL code here with comments that it's more tailored to the specific issue we have in our code, alongside some nice explanation of what's going on. If you want a step-by-step explanation, just 5 days ago, we released this / command, and you see some explain, fix, help, tests. It's some predefined prompts that help GitHub Copilot and us to be faster towards that direction. So if I continue with the explain, we can do explain the CodeQL code you have suggested just above. And here's a, let's go for a step-by-step. Can I have a step-by-step explanation of the query you provided us with above? I included you as well. I'm going with the us, not with the me. OK, here you go. We have a step-by-step explanation, which also minimizes the steep learning curve that someone might say CodeQL has. So step-by-step explanations brings us to the next demo of today. I would like you to put yourself in the shoes of the developer who has received this CodeQL security alert about a SQL injection. You might go to your favorite search engine and try to build some background about this vulnerability, or on YouTube. The problem is that what you get might be inaccurate, or it might be outdated, or not suited to the specific framework or technology that you are using in your code. I would like to mimic that in the GitHub Copilot chat. So can you please explain SQL injection? I'm going on the very generic prompt here. Nice. What we have on screen is the theory of SQL injection with some basic standardized examples that someone can infer that you can find everywhere. Why I'm showing you this? Because the next step is to get tailored developer training based on the specific issue you have in your code. Everybody codes differently. We try to use GitHub Copilot as your coach of developer training next to you. And to do so, I will prompt like that. I have a hard time, and I'm vulnerable in this one, understanding the theory of SQL injection above. Can I please, let's do we. Can we please get some code snippets in the form of examples that have to do with a specific variant of SQL injection as seen in line 59 and line 60. I'm someone who fails to connect sometimes the theory to the applications. SQL injection occurs in dozens of ways. I've seen parameterized statements in my career and still be vulnerable. So what I'm trying to get with that is to get more specific. So if I scroll up, you get, certainly, here are some examples of how an attacker could exploit the SQL injection vulnerability in line 59 and 60 of your code. That's the first one, where we go with the logic bomb, which is pretty standard, and then we get a specific explanation of how it can look in the code. Before GitHub Copilot, as security specialist myself, I will literally have to go step by step, injecting, putting the codes, etc. This is a massive step for me. We can also see the example of dropping a table, and we can see also how it can be prevented. Now, just before I show you the final slide of today with a summary of what we've seen, I would like to touch on privacy. And I would like to touch on that because there's a common thread I see about GitHub Copilot and privacy that I think is important to address. If you have a GitHub Copilot business license, then your private code, your prompts, and the code suggestions you receive all remain private to you. We retain nothing. As an individual user of GitHub Copilot with an individual license, you have the chance to opt in or opt out as many times as you like from making the product a better tool for everybody else. And of course, you can ask us to permanently delete your data if you so wish. And with that, I would like to go to the final slide of today that summarizes the 3 ways we have seen through 7 demos with which GitHub Copilot can help minimize the gap in software security. The first one was to fix bugs and write safer code, of course, with the necessary disclaimers. The second one was to discover and customize CodeQL queries. And finally, to receive tailored developer training based on the specific issues in your code. Just before welcoming Bryan back on stage, I would like to highlight how excited we are about this technology and confident that, if used correctly from developers, can minimize the gap in software security. Back to Bryan to take us out.
Thank you. That was awesome. All right, last slide. Like, how do you get all of this? So, Gazdo public preview, again, sign up at aka.ms. Advanced Security sign up. I love that everybody's taking pictures of it. Yes, do that. Defender for Cloud. I hope you love what you saw about Microsoft Defender for Cloud too. I think that is an incredible product that really comes together with Gasto. And then again, like all the amazing, amazing security work you just saw from Joseph. You can sign up for access to Copilot and an AI playground at github.com/feature/preview/copilotx and GitHub or GHIO Copilot demo. So again, thank you all so much for coming.